everybody, Philip Whiteman here with Laketec Communications. This is part 3 in our VXLAN series where we had already covered deploying the layer 3 underlay in a campus environment. And in this video we're going to cover deploying the overlay using Aruba's net conductor wizards. So there is a little change in my topology here. We have the same core, ag, and access. We're still going to do point-to-point layer 3 between all of these. However, I want to demonstrate a brownfield environment. So in a brownfield environment, typically we'll have things like, trunking to a server farm. We'll have some internet connectivity. And in this example, I've obviously got clients connected. And in here, we're going to do, we've got VSX configured. So we have a redundant aggregation layer here, where we've got keep alive interfaces and lags for the redundancy. And I've also got layer 2 extended down to my access layer, just like anybody has that is not using VXLAN across their environment. So with layer 2 extended, I still have the point-to-point layer 3s that we demonstrated in the other video. So we still have full OSPF adjacency between everywhere using layer 3 and point-to-point links across the environment. Okay, so yeah, those are all still there. So we got layer 2 and layer 3 going across these links. So I think what we'll do next is that we'll get on to the we'll jump over to the switches here, and we'll show what we have configured for VXLAN. So those are 6 switches. They're all currently in sync. I have absorbed those configurations into Aruba Central. And if we look at the switches now, we have no VXLAN configurations. So we have no BGP EVPN configurations. We have no VLAN 100 interface, which is what we're going to be deploying. So we have no VXLAN interface here. We have no EVPN configuration. We have no VLAN 100. And then same thing on the ag layer here. We have no VLAN 100. We're not stretching layer 2 between the two for those. We have no BGP configuration, no EVPN configuration. So this is strictly just a brownfield, again, deployment where we have OSPF between all devices, as we demonstrated in the last video. Except now we also have some layer 2 going down, and we're going to mix that together with some VXLAN. So we're going to use our fabric wizard, just like we used our underlay wizard before. We're going to call this campus, actually I want to call this campus overlay, because we're going to be deploying an overlay network. And we have some advanced features here where this VLAN client presence detect will actually look for the presence of clients participating on a VNI. If we don't have a client, we're going to use VLAN 100 in our example. If we don't have a client on VLAN 100, it's not going to advertise that out through EVPN to the other VTEPs because there's no point. It doesn't need to know that it's participating in 100 because there is nothing there for it to hear. So as we talked about before, we have our personas that we're going to define. So we have our access, ag, and core, and the core is not going to participate in our fabric at all. So we could, like we talked about the VPN example where we're just cutting through the internet. Who knows how many routers? That's demonstrating that. Here we are going to have our aggregation and our access layer participate in the fabric. So we're going to define those personas appropriately. So these two guys are actually going to be a logical pair because, again, they're running VSX, and then the access is going to be an edge that's going to route across the layer 3 environment, the rest of the infrastructure there. Okay, so let's get those defined. So here's another pictorial of it here. We're going to go ahead and we're not doing anything with the AOS gateways. Again, that's like Aruba controllers, Aruba gateways participating in VXLAN. So we're going to define our 2 access layers as edge, meaning that we can deploy layer 2 VNIs to them. And then for ag, we're going to make them border so that they can translate getting things off of VXLAN and onto the underlay through routing to the external network. We could make them edge devices. We're not going to, because we're just demonstrating that all of our VNIs are going to be defined on the edge. We could make them that, but we're not going to. And of course, they're going to be route reflectors for the EVPN. So once again, defining those, could make it edge, we're not going to. And then the cores, we're not going to do anything with those. We're not going to deploy any fabric to those at all. Again, demonstrating we can have any layer 3 networks between this infrastructure. Okay. So it is, I'm going to rename this here because, so what this is, it's our overlay VNI so that, that we can do routing within VXLAN. So when we do that, we call it a layer 3 VNI, and everything participating in the fabric will have this layer 3 VNI so that we can route from, say, VNI 100 over to VNI 200. And there's a couple different ways to do that, whether it be asymmetric or symmetric. I'm not going to get into here, but this is giving us the ability to route between different VNIs. So that's what that is here. Okay. So as you can see, there's a bunch there that we could define, but we only need one. All right, so we're not going to do any tunnels of the gateways as we previously discussed. We don't have any gateways in our environment, so we can skip that step. All right, and here we are. Here's our configurations. So let's go ahead and push it. All right, let's take a look at the switch configurations here. So we don't have any BGP configurations yet. So as Aruba Central calculates that, it's going to go ahead and deploy those down to the switches here, which should happen momentarily. Okay, and here we go. So now we have BGP configurations. So everything's starting to synchronize. So as you can see here, we have the VRF overlay, which we talked about a minute ago. That was that 10.100 or whatever it was, so that these switches can route internally within VXLAN. Of course, any traffic that is going to a network that's not participating in VXLAN will need to go to the border router. Okay, so here we are here. We have no EVPN configurations yet because they're not going to be participating in VXLAN layer 2, but we do have the overlay network over there. Okay, we have nothing in our EVPN table because we don't have any clients participating in VLAN 100 yet, because we haven't defined VLAN 100, but we do see that in order for our VTEPs to reach one another, that we have a table here that defines what's what. So it's saying that in order to talk, for my 127 switch to talk to the other two, it knows that there's VTEPs at 25, 26, and 28, and that we can use those VTEPs for routing wherever that needs to be. Okay, and just another view of the same thing, just a little bit more detail. Okay, and it's actually showing which point-to-point interface it's going to use. It's 3.17 across lag 1. All right, so we need to get some clients on VLAN 1, or excuse me, VLAN 100, so that they can participate in VXLAN. So we have VTEP configurations already. That's what we just pushed to our edge switches, and we have a VTEP configured on our AG switches again for the L3 VNI routing. So we will see VTEPs there, but what we won't see is we won't see any VNI configurations that we'll have at the access layer, because VLAN 100 is only going to exist at the access layer. So make that a little more clear here. We are not extending VLAN 100 up to the AG. It's not going to be participating in layer 2 or layer 3. So we're going to put these two guys on VLAN 100, and just to show that that VLAN again does not exist yet on our access layer. But let's go ahead and let's configure it. So on our fabric, we're going to create a new segment, and it's going to, if it needs to route, it's going to use the overlay. And we're going to call this data. We'll go to VLAN 100 because it's really easy to remember. And I am using the 1030-100 network just because I already have DHCP servers and everything upstream configured in our environment to handle that network. So here we are here. So we're going to define those DHCP server here. That's good. So now we have a DHCP relay. We're not going to do roles right now. That's for microsegmentation. I'm going to be covering that in the next video. So this is for inserting the role into the VXLAN header so that we can do microseg, which again we'll do in the next video. Okay, we only have 2 edge personas, which is our access layer. Again, if the ag was in here, I could have deployed that to the aggregation layer. It would also then have VLAN 100 with layer 3 gateways for 1030.101. But just to again demonstrate that we're cutting through that environment, I'm only doing it at the edge. Okay, so let's see here. Let's see, no VLAN 100 yet, but it should be coming down here momentarily. Okay, anytime now. There we go. So we have a VLAN 100. Very good. And if we do the show run interface, we see we have a layer 3 presence for it here as well. So we have an active gateway IP, or an Anycast IP if you want to call it that. It's 1030.100.1. This is the gateway that's going to be issued to DHCP to the clients as they connect to the network. And if we look over on access B, we should see that we have the same VLAN 100, and we do, and it's got the same exact layer 3 gateway. So this is what makes it possible for clients to be distributed across the campus, but still be able to get to their gateway, and then encapsulated to stretch that layer 2 across the environment. And in this case, this is a gateway for them to get off net. Maybe they're going to another VNI, which then will use a layer 3 VNI to route between the 2 networks, or they're going to get off net and go to the border router. So again, just showing that there is no VLAN 100 here. So the clients can't broadcast for the MAC address of the other client. So there's no VLAN 100 here. Nowhere in this environment. We do have the point-to-points, however, so we're going to route across those point-to-points for those VTEPs to establish communication for the 2 clients. So show that again here. So here we do have a VLAN 100, but we don't over on the ag layer. We can see that for VLAN 100, it's only over on the so my 127 switch only sees VLAN 100 over on the 128 switch, which is true because we only deployed it to those 2 switches. So same thing here. We've got our 128s that sees VLAN 100 only on the 127 switch. It sees the 2 ags for the layer 3 VNI, but not the VNI for VLAN 100. Okay. All right. So let's put some clients on VLAN 100. And actually, as part of the wizard, it does set up a source interface for the DHCP relay, which I don't have actually configured properly on the DHCP server. So I'm going to take this out of here so that when we do the DHCP relay, it's actually going to relay off the VLAN interface and not from the loopback address. So that's what we're doing there. And now let's go ahead and put some clients onto VLAN 100. I've got several clients that we're going to set up for our next demonstration. So we're going to have like an employee and a contractor, an IoT device, all on VLAN 100. And in our next video, we're going to prove that they will not be able to talk to each other, or can talk to each other, depending on how we define policy for the microsegmentation. Okay, so now that we've done that, so we defined VLAN 100 and 111, 112, and 113 on both access A and B through that multi-edit configuration we just did in Central. So let's see here. There we are. So we have an interface that is now in VLAN 100. Okay, so that's great. And very basic config. It's just an access interface on VLAN 100. Not much to it there. Let's check over on this switch and make sure the config came down here, and it did. Okay, so we have interfaces on VLAN 100, 2 separate switches. That VLAN is not extended across the 2, as proven out like 5 times now. So we look at our EVPN table that's being built. It has discovered a client, so this switch has discovered a local client. It's picked up its IP address as well. That it's learned through the client tracking above. And if we look at switch B, it sees that client over on switch A, but it sees it as a remote client. So it's remote. So it's building the table saying, hey, in order to get this client, I need to go to the VTEP that's running on 127. So as it encapsulates the traffic for this guy, it's going to send it to the 127 switch on the remote switch here to de-encapsulate it, because this is the switch where the clients reside. Same thing here. It's learned a .13 address, so the .11 is local, as you can see up there, and the .13 is remote. It's the opposite on this guy. So we have a client on each switch, both of them. So we got an 11 and a 13, both of them on separate switches. Okay, so let's go ahead and look at actual connectivity here. Why don't we RDP into these guys? Which, by the way, we're coming from upstream, like on the other side of the border router, to get our traffic encapsulated in VXLAN to get down to these clients. That's how I'm establishing my RDP. So the border router is what's coming into play here to make it so I can reach these guys, because the computer I'm doing my demonstration on here is not participating in VXLAN. Okay, so I've got started both my RDPs. Okay, gonna get them side by side here, so we can snap this in, or not. That's not what I want. It's not snapping. That's okay. I'll resize this manually. Okay, cool. So let's take a look at the IP, just to make sure we know what we are. So yeah, so we're .13 and .1 is our gateway. Let's make sure this guy is truly .11. He is .11. .1's our gateway. So let's see if we can reach each other here. Okay, put in the guy over on the other switch. There we are. Okay, same thing here. We'll reach back across the other way. Perfect. So these guys that are now layer 2 adjacent, because layer 2 is being stretched across the environment via VXLAN. So voila, pretty cool, huh? So we're going across VXLAN from this switch to this switch to establish that layer 2 communication. And again, this could be the other side of the campus. It could be a completely different campus. It all works the same. This is just a simple demonstration showing that. So awesome, mission accomplished. So I think in our next video, in our next video, we're going to cover that group-based policy where we're going to demonstrate microsegmentation, where we're going to have 2 or 3 clients in the exact same VLAN, but not allowed to talk to each other, or maybe talk to each other. See you there.